Hello, Professor. My name is Abdulgafar Tolari with student ID 101462578. Yeah, I'll be showing I'll be introducing the assignments. In, in this video, we'll be building and training a neutral network to classify iris flower species based on the septal and petal measurement. Then we will go through loading data processing, building a neutral network, training and evaluating it to see how we can perform. And then we have to train a deep learning model that can accurately predict the species of an iris flower. So let's just dive in. This is actually my name. So if I load it, it's give me stuff. Okay, let's try to load it and see. Okay, I load this one. So and want us to go since the instruction was for us to go to have our file inside. In this I have my file. I already have my file inside my diary. So it's asking me, okay, I should connect Google Drive, which was already connected to. It was connected before, so I should try to run it. Connect to Google Drive. Okay, let me try to connect it. Okay, this is my Google Drive. It's gonna ask for verification and everything. Everything was done already. So it shows that I have it inside, which is just connected, right? And this is the Google Drive that was connected. So I have it here. Um, inside my drive, I have my assignments. I was inside my drive, which is this here. So I already run it here, which is run. So we have to load the data. So I already load the data, as you can see, and then we load the data from the CSV file using pandas. And the data contains the sepal and everything. So inside the data, we display the first few rows to inspect the data, which is if I should run it, that's my first few rows that was displayed. And then we have to convert the species name to the species column contains test labels like Setosa, various color and this one, yeah, and the Virginica or something. Then once I run it, I have it as is running. Then I check it to print the just to print it, so which is running as well. Then for the battery, then it says we should train the test split, which it says select the first four columns of the data frame as the data hand call the data hex, right? Once I do it, then because it gives me my namespaces, data type, and integer and whatever that I have there, right? Then it says split the data into training and testing of 80% from sk.model, which was what I did here. Once I split it, I have my agent and I have the S training head and I have the test head and the print y train head as well for me to have everything for it to get to what we originally have to do from what the professor asked us to do. Then it says check the length of the S string and S text. If the numbers are 120, 130, then we should say successful once this number was actually incorrect. And then so once I print the length of the S string, then I print the length of the S test of confirming if the sizes are correct. Then once I try to train these, then I have my length to be 120, then I have my test to be 30, then it says awesome, you are good to go, which was instruction that was given for us to do then. In this part it says I think that is the part 5. What did they say? It's, it says convert white train and white test to one auto encoding which else import pandas. So I have to import my pandas again so that because once I then I print the high res just for me to get the actual basis there. So this was actually what I did here. Then I select the features of X and the labels Y. Then I have the X of the iris to lock all features and the labels and perform train test split for each, right? So because I'm actually doing everything from my sklearn, right? Because I already trained the model for it to get to what I'm actually doing, right? So once I try to train the model, then I try to run this part. So it's still running. So it gave me one encoding completed successful shape of one of not encoded was 120 and 3. Then the shape of one encoded, which is right there, gave me what I really wanted to do. Then it says define a sequential model with three dense layers from tensions and import sequential from. Then we import the sequential. Then I did the Kera import dense as well, so that I can get the shape on of this those sequentials, right? Which is what I run, and it actually gave me the proof. And this part, it says we trained the model using 20 herpes with a batch size of 10. The data is divided into mini batches for efficient training, right? And we have the validation accuracy, which is monitored to check performance on scene data. Then we have to train the accuracy maybe 50 to 86 lows. Then we have the second on this part we have the first one, which is 50.80, which is the lows dot 105, and we have the other one that is 70.48, that is lows of 0.75 as well. Then we have this one at 67.68, which is lows of 0.63. Then the fourth part too, we have about 96 point um 83.47, which is the loss of 0.50 as well. So once I try to run the history, then it gives me the 20 encoding of what I did in the first place. So it's just to show that it was actually right. Then we have to check the accuracy of after training. Then we evaluate the model to test the sets to check its final accuracy, right? Which is what I did here. Then it gave me the accuracy of 0.933, right? Then we compare the model, then we compare the model, right? So the larger model mirrors the smaller model. The larger model significantly outperforms the smaller ones, which is what was actually done here as well, which was still what everything I did in that aspect of it. Well, this is just a well-designed neutral network can achieve high accuracy for zero calibration. And larger models like 100% outperform smaller ones. And I train it with one more improves accuracy, but requires more overwriting, more computations as well. So yeah, that is what basically what I did in in this assignment as well. So I just tried to load everything and everything was working perfectly. Yeah, thank you.